Example, find the eigenvalue and eigenvector of a matrix A contain the element 10, minus 9, 4 and minus 2. First, calculate the matrix A minus lambda I. We have A minus lambda I is equal to A is a given matrix minus lambda multiplied by I is an identity matrix such that the order of the identity matrix I is equal to the order of the matrix A. And after the calculation, the resultant matrix is contain the element 10 minus lambda minus 9, 4 minus 2 minus lambda is a resultant 2 cross 2 matrix. Now the characteristic equation of a matrix A is given by the A minus lambda I determinant is equal to 0. That is, the determinant of this matrix is equal to 0, and after the expansion and calculation, the value of lambda is equal to 4. And this equation is a characteristic equation of a matrix A, and the value of lambda calculated from this equation is equal to 4 is an eigenvalue of a matrix A. Therefore, for lambda is equal to 4, for an eigenvalue lambda is equal to 4 of a matrix A, we have to calculate the eigenvector x. Let x be an eigenvector of a matrix A. For an eigenvalue lambda is equal to 4, then the scalar lambda and the vector x satisfy the condition that Ax is equal to lambda x. A is a given matrix, is a required matrix X. Then after the multiplication and simplification, we have 10x minus 9y and 4x minus 2y is equal to 4x and 4y, and these are 2 cross 1 matrices. In according to the condition of equality, we have 10x minus 9y is equal to 4x, and after this multiplication, the result is equal to 2x minus 3y is equal to 0, and 4x minus 2y is equal to 4y, and after the simplification, the result is the same, 2x minus 3y is equal to 0. Solving 2x minus 3y is equal to 0, we have the value of x is equal to 3 and the value of y is equal to 2. Therefore, for the eigenvalue lambda is equal to 4, the eigenvector x, which is a column vector, the value of x is equal to 3 and the value of y is equal to 2. Therefore, x is a column matrix is an eigenvector for an eigenvalue lambda is equal to 4 of a matrix A.